What if we could turn off aging, the biological cost? What if I told you we could turn off aging? Not slow it down, turn it off. Scientists have already done it, in mice. But here's the part nobody talks about, the cost. Aging happens because of telomeres. Telomeres are protective caps on the ends of your chromosomes. Every time a cell divides, telomeres get shorter. Eventually, they're too short and the cell stops dividing. You age. But there's an enzyme called telomerase. It rebuilds telomeres. It can make cells immortal. Some cells already use it. Your stem cells, your reproductive cells, and cancer cells. Yes, cancer cells are technically immortal. They activate telomerase and divide forever. That's why tumors grow uncontrollably. So here's the trade-off. If we activate telomerase in all your cells, you stop aging, but you also massively increase your cancer risk. Your body evolved aging as a defense mechanism against cancer. Cells that divide too many times become dangerous, so your body forces them to stop. That's aging. Turn off aging and you remove that safety lock. Scientists are trying to find a middle ground. Activate telomerase just enough to slow aging without triggering cancer, but it's a razor-thin line. There's another cost. Immortal cells might stop responding to signals. Your immune system relies on old cells dying off and being replaced. If they don't die, your immune system weakens. You might not age, but you become vulnerable to infections and diseases. Here's the uncomfortable truth. Aging isn't a bug, it's a feature. Your body chose a slow decline over immortal chaos. The question is, would you make a different choice? Subscribe if you want more biology that makes you rethink everything.